Hey guys, what's up? My name is Gabe and this is Games with Gabe. This is the next episode in the Jade Engine devlog. So I've been spending way too much time trying to fix up these windows and everything, and I feel like it's time to actually start implementing dragging and dropping the items back into the screen again, and then implementing some physics. So that is what I'm going to try and get going in this devlog, is to just get the drag and drop ability back into the game, and then implement physics back into the game as well. So let's try and get this done and see how it goes. So it has been 1 day since I recorded that last clip, and I now have drag and drop back in the game. So you can now drag the items back into the game and select different things, and you can select them and move them around just like I had in the version that I was doing completely Java with. As you can see, I still have some glitches. Places the right character, but the preview sprite is wrong, which I will get around to fixing. But for the most part, it is working as it should, which is great. And so now I can start working on the physics. The way that I've coded this is actually going to help me a lot when I go to implement the physics. The way this is coded is it has a world partition, is what I called it. So basically I partitioned the world into grids, and this is one grid square, which makes sense because we have this grid. And this will make it really easy when I go to do the physics, because if I'm testing physics detection, I can just check and see if there's an object below the character. And if there is, then he can't move down, and so on and so forth. And as you can see, it already has a little bit of a primitive physics detection, because when I'm moving him around, I can't move him over another block. But this, of course, isn't the full physics that I want implemented. I want there to be gravity, there to be friction, and then of course you want there to be different enemies and stuff running along and be able to detect when you hit the top of one of their heads and stuff like that. But it should be fairly simple, I'm hoping. It's been a day since I recorded that last clip once again, so I keep saying these things should be simple and they aren't. So yeah, I'm going to try and implement that physics now, and I'll update you guys once I get something working. Alright, so another quick update. I know I said I was going to start working on physics, and I really am going to start working on physics this time, but there was another pressing matter that I had to fix, which was re-enabling the saving of the window positions and everything. So now if I exit out and re-enter, you'll notice it saves what position I was in, and then I also had to fix importing and exporting levels. So now you see I'm on the default level, and I fixed it so that once again you can switch to different levels that you've been editing, and you can start new levels as well. So you could do like new level here, and then it would start one, and you'll also, once you save it, you'll notice that it shows up inside of your levels. So those were some pressing matters that I just had to get done before I could actually start implementing the physics, because there's no sense in having physics if you can't really switch between levels. One interesting thing was, you'll notice that this is using native file dialogues, which I really like, and I'm happy that I could do this, because if you remember from the previous one, it was using Java's built-in, ugly, gross, old editor, and it just did not look good. And so now I can actually use the native file dialogues because of LWJGL. They have a binding around a C library called native file dialog. So no matter what operating system you're on, it will show up the way it should. But I'm going to start working on the physics, and hopefully that's what my next update will be about. Alright guys, so I have the physics complete. I'm recording this in post to the recording that you're about to see. I just left out a few details. I didn't really explain how the physics was working or anything too, and I wanted to rectify that by adding in this little bit of information about how I'm performing the physics, and also talk about my animation system that I implemented, which I'm also pretty proud of. So it's pretty cool. Now, physics. The way that I implemented the physics is basically the world is divided up into this grid, as I explained, the world partition. And so for static objects, we know they're not going to move. So these are static objects, all the blocks that don't move. Dynamic objects are like characters and enemies, etc., etc. So for the static objects, it's really easy for me to check. I don't have to check collision on them because I know they're not going to move. So I only run collision on dynamic objects. And for each dynamic object, what I do is I check in a 3x3 grid around them, and I see if there are static objects in the grid around them. So that way, if they're in between, I will make sure to get all the blocks that they could be potentially hitting. Then if there is a block, for example these three down here, what I will do is I will run collision detection on each of them, and if the player is colliding, which he is with this block in the middle, then I do my collision resolution, which means I separate the player from the block that he's colliding with, and then I continue to run physics as it would normally be run. Now, I was running into a problem where, say you were the player and you were running to the right. Well, what would end up happening is he would sink into the ground just a little bit, and then he would clip on this block to the right, and so then he would stop like he was hitting an invisible wall right here. That was not good. So I looked up how some people rectify this situation, and what I found was that they said best way to do is basically if you have blocks like these which are lined up in a row, just don't perform collision detection on the left and right bases. So quit performing collision detection. So I added in a clause in my code that would basically say if they are lined up to the left and right, don't bother checking collision, which fixed that problem and made it nice, because there's also problems where if you were falling to the right, you could hit an invisible ledge right here, which means you could glitch the game and win when you shouldn't really be able to. So then for dynamic objects, the way I also check collisions, because static collision is easy, you know they're not going to move, but what about dynamic objects against dynamic objects? If the player's about to hit this Goomba, how do you know that? Well, I didn't do anything fancy. I'm literally just looping through every single dynamic object and saying, okay, check and see if he's hitting this Goomba or any other Goomba or dynamic object in the scene, which is not efficient and I would definitely do differently, but given that there's not going to be many dynamic objects in the scene at once, I think this will be fine. If it starts bottlenecking and there are issues, then I will look to resolve this, but for now it works perfectly fine and I'm good with it. Now, animation system. The way that I did my animation system, if you've ever taken a fundamentals of automata class or an automata class, you learned about this thing called finite state machines, FSMs. And with finite state machines, it's really just fancy terminology saying, basically, let's perform a state checker, a state transition, a state checker. So say you have state A and state B. You want to say transition from A to B on 0 and transition from B to A on 0. And then transition from A to A on 1 and transition from B to B on 1. And so basically, the way that you can use this with animations is say, instead of these generic A, B, 0, 1 states and stuff, say you have a state which is idle, and then you have a state which is running, and you have a state which is jumping, and then you could have a state for swimming, so on and so forth. Then you could say switch from idle to run on start run, and you could say switch from jump to run when you say start run, and so on and so forth. And so this is what I did my animation system. It's really nice and it makes it so much easier when I'm doing things. And so then this is very a Unity-like way of running my animation system. So basically, if you are coding and you want your player to switch from idle to run, all you have to say is get his animation machine. So this whole thing is a machine full of animations, and you basically say machine.trigger, and then you give it the trigger you want to send, which is just a string, and it would be like one of these strings. So start run, start jump, start whatever, and then you would just say start run, and then no matter what state the player is currently in, the animation machine switches to the correct new animation. And this also contains information about whether the animation should loop or whether it should stop after the first time and just stay on the last frame and stuff like that. So it works really nicely and it does everything exactly the way I need it to be done. I'm really happy with the way it turned out. Now, I know you guys probably want to see how the physics turned out, so here comes what the physics turned out like. I have made leaps and bounds in the progress of this. I now have physics working, so you can see that Mario can now run, squash the enemies, and has successful collision detection with all the blocks. And the physics works pretty good. I'm really happy with the way it's turning out. And then also, if you hit the top of a block, then it bobs up and down just like it should. Right now, nothing's coming out of these because I haven't hooked that up, and also you can bob these blocks too, which shouldn't be happening. And I will fix it. I already have the mechanisms in place to fix that, but I just haven't implemented it yet. And you also notice he moonwalks. I still haven't implemented flipping sprites, which will be my next course of action to fix that. But I'm really happy with the progress. It's looking really good. I think it's coming along really nice too. My next course of action is probably going to be, like I said, flipping the sprites, and then also implementing a little pop-up window so that when I add these blocks in, I can select what kind of item comes out and everything. And then also just polishing some things, and then flipping the sprites. Like I said, I think I said that like 3 times now. But also implementing some portal functionality with the tubes. What I plan on doing with that is basically having a handle pop up on certain, there will be like a prefabricated one, which is a tube you can, or a pipe you can go through. And then I want there to be a handle that you can click and drag to the connecting pipe. And that connecting pipe is where you will appear in the game world. So some more level editor stuff. I think that'll be fun to implement and just see how that works and everything. And I'm really excited to see how it turns out. But I think this is going to cover it for this devlog. It's made a lot of progress. Physics is working. We now have fully rendering, and we have level navigation. You can create new levels and start new levels and everything. So I'm just really happy with the way this has turned out. I hope you guys liked this. If you did, please hit like and subscribe. And remember, if you hit subscribe, you will be getting tutorials about how to make all this in the very near future. All right, guys. Thanks. See ya.